Before we even get started talking about what our application is going to do or any programming, I want to quickly go over why we would even choose Go as a language choice in the first place. So, why would we choose Go? First off, it's extremely performant. At this point, I've written at least a dozen Go applications, and never once have I needed to hunt down any sort of race condition or performance issue. And one of those was an API for a fairly large startup. We had about 10,000 users, and at some points, 1,000 to 2,000 simultaneous users. And even then, we never had any major performance issues, and that was running on a 4-core virtual machine. Go is also extremely compact. So the application runs from typically a single main.go file, and that can be done simply by issuing go run main.go. As we'll see later on in the course, this is extremely powerful for when we want to Dockerize our app. It's very simple to transport and run a Go application. Go is also extremely testable. It has a testing framework built in. So we would import this testing package, we pass that into our testing function, and then it's as simple as calling the function that we want to test. And in this case, I've returned an error from this function. If the error is not nil, this is Go for not null or empty, then we use this pointer to the testing framework and we issue an error. So this is built in. We don't need any external config. We don't need any external libraries. It is built into the language. Go is also extremely API friendly. So I have an example here to show you how it works in Go. So if we assume we have some sort of JSON response from an API like this, we can use the JSON package and also the JSON identifier when we define a type here. Call it some API, it's a structure. And we know that our response has some int of type int and some array of string. It's a string array. We use this JSON identifier. Now, the magic happens when we use these identifiers and we use the built-in JSON package. Let's assume that we already have the response from the API, some sort of binary result. We can simply call JSON unmarshal, and Golang will serialize that binary result into our response object. And when it sees these keys, it knows to put those values in each of these parts of this struct. So then if we went to, assuming no error, unmarshaling the response, if we went on to log out some int, we would get 5. And if we looped over the array of strings, we would get this A, B, and C. So again, we don't need any config files, any external libraries. We just use the built-in JSON library with the unmarshal method, and Golang handles all the serialization and deserialization of JSON right out of the box. Golang is also extremely uniform. So when you're writing Go with a modern code editor like Visual Studio Code, Go formats on save according to its own built-in rules. And this means that no matter where you're reading Go code, whether it's an external package, a third-party package, your teammates' code, you will always see the same patterns, indentation, and spacing on any Go code. This makes it very easy to read other Go projects. This also saves you and your team time from debating about formatting rules like tabs and spaces and all these things. These rules are also built into the Go language. So, in summary, Go is very performant, it's very fast, at least in all the experience I've used it. It's very compact. You just need your single main.go file. It's easily testable. Testing comes with the language itself. It's very API friendly. This JSON serialization and deserialization also comes right out of the box with the language, and it's uniform. These linting and formatting rules also come with the language. And so altogether, Go is a very solid choice for any back-end software that you may need to build. So with a basic background of what Go is and some of its advantages, in the next lesson we can start looking at the actual application that we'll build, and then we can finally get into coding the application.